So in the continuation of the previous lecture, we would like to continue the effects of alloying element. So let us take one by one. The first alloying element is carbon. Carbon content is steel affects the following things. It affects hardness, tensile strength, machinability, and melting point. So carbon content in the steel, as we seen in the iron carbon diagram. So 0 to 2% addition of carbon into the iron, it forms steel, and more than 2% of carbon addition, it forms cast iron. As we see the classification of materials, we could clearly understand. The next alloying element is nickel. So increases toughness and resistance to impact. So lessens the distortion in quenching, renders high chromium ion alloy austenitic, does not unite with carbon. These are all the effects of alloying nickel with the elements. So coming to the alloying element chromium, joined with carbon to form chromium carbide. And when we add silicon, it improves oxidation resistance. So oxidation resistance, when it improves, the corrosion resistance will get decrease. Strengthens low alloy steels, acts as a deoxidizers also. Then the purpose of alloying titanium is to prevent localized depletion of chromium in stainless steels during long heating and prevent formation of austenite in high chromium steels. Let us see one of the important alloying element, that is molybdenum. It promotes hardenability of steels, makes steel fine-grained, raises tensile and creep strength at high temperatures. As we have seen, creep and fatigue is one of the major issues in withstanding high temperatures for a long time. So it raises tensile and creep strength at high temperatures, enhances corrosion resistance in stainless steel. So corrosion resistance is being enhanced in stainless steel. We all know stainless steel is steel which we use for utensils, our own domestic, all the materials we use, stainless steel. It forms abrasion resisting particles. And vanadium, it imparts strength and toughness to heat treated steel. It is a powerful carbide former, stabilizes cementite and improves the structure of the chill. So these are all the purpose of adding vanadium. So coming to the next alloying element, tungsten. So it improves red hardness or hot hardness. It promotes fine grain, resists heat, promotes strength at elevated temperature. And when we add manganese as an alloying element, it contributes markedly to the strength and hardness, counteracts brittleness from sulfur, lowers both ductility and weldability if it is present in high percentage with the high carbon content in the steel. So these are all the purpose of adding manganese to material. And we have copper. When we add copper as an alloying element, it increases resistance to atmospheric corrosion. It acts as a strengthening agent, and boron increases hardenability, depth to which steel will harden when quenched. So we have boron in cutting tools. Aluminium. So aluminium acts as a deoxidizer, produced fine austenitic grain size. If present in the amount of about 1%, it helps in promoting nitriding. So the effect of alloying cobalt, it contributes to the red hardness by hardening ferrite. It improves mechanical properties such as tensile strength, fatigue strength, and hardness. Refines the grains, graphite and perlite. it is a mild stabilizer of carbide. It also improves heat resistance, retard the transformation of austenite and thus increases hardenability and freedom from cracking and distortion. So this is the small assessment link which I will share with you to go for small assessment in this effect of alloying elements. Thank you all for the patient listening. We'll continue the rest of the things in the next lecture. Thank you.